Now what is asynchronous? Opposite of synchronous means there may be some signal which is independently working without the synchronization of clock, means the signal which is not dependent on the clock, that signals are our asynchronous signals. For example, reset in flop or set in flop, whenever there is reset the clock output is 0, so it is asynchronous, which is not related to our clock and useful for bringing system into known state at power up. For example, if chip has any fail safe, so fail safe system should be asynchronous now, because if it is synchronous with the clock then chip will not work properly. Whenever there is a problem it should directly go to power down, that signal should be asynchronous. And it is trickier to verify because we don't know when it will come, because if failsafe is there then it is unpredictable, then something might have happened. That's why it is trickier to verify asynchronous signal. Potential glitches and metastability is not carefully synchronized because that signal is asynchronous, so we cannot predict it. If there is a metastable state or there is a glitches in that signal, we cannot see. Now let's understand this concept with the help of a graph. Now assume this is our clock at passage of clock and our data is there. Now reset can come any place, it will not depend on our clock, but data is our synchronous signal, so reset is not our synchronous signal and our clock is synchronized with our data. So data is x. Now here active edge of clock there is our reset in middle, and now we have to follow reset because it is a synchronous signal until next edge of clock is 0, again the reset is there, then also we will say it is 0. Now it is 1, then also it will be 0 until next edge. Now it will say that signal our reset is actually low, then we will see that data can be there, it will be 1. Now this is our asynchronous signal reset, whenever it is coming we have to follow it. Now for example in clock, here in our code to do this concept with the help of a graph. Now assume this is our clock at passage of clock and our data is there. Now reset can come any place, it will not depend on our clock, but data is our synchronous signal, so reset is not our synchronous signal and our clock is synchronized with our data. So data is x. Now here active edge of clock there is our reset in middle, our clock is our passage of clock and our reset is also passage of clock, which we seen previously. Whenever there is 1 then only we are doing our data 0. I have explained that example with our D flop example. Now asynchronous we have used here counter code, so whenever the count is 0 at passage of reset and it will be independent of this clock, and count is incremented with the help of our synchronization with the clock. So here both the things are working together. One signal is synchronized with clock and reset is asynchronous, it is coming independently and doing our signal to reset to 0. So this is, we used our synchronous and asynchronous concepts in our Verilog coding, and this is a very good example of counter and D flop which you can use in your interview. So 1 or 2 year experience engineers can have this question in any interview. So thank you for watching this video, and whatever concept you need you can comment it.